We've now seen different uses of plots. We've been mostly comparing orders of growth, which we've seen before. I wanted you to see the idea of how plotting lets you visualize data. And now I want to turn to a variation of that, which is to think about how can we actually use that visualization of results to help guide computation, to help guide the values of parameters we might want to pass in or the kinds of things we want to explore inside of a computation. To do this, I'm going to use a simple little example. Imagine you're planning a retirement. You want to think about making sure you got enough money saved away so that you can retire at the age you want. Let's look at basically how a retirement fund grows with compounding of interest. And I'm going to do it with the following simple little example. I'm going to plan to set aside a particular amount, let's call it M, every month out of my salary. Save it away in a retirement account. I also expect that I'm going to earn a little interest on that. I'm going to invest it in some stocks or bonds or C-bills or something else. So I'm going to expend to earn a percentage R of additional income every month on the investments I set up. And I want to explore how big is my retirement fund going to be when it compounds over time with both new contributions each month and accrual of interest each month so that I can decide when I want to retire. How much do I need to have before I'm ready to actually retire? Let's look at how we might both write code to do that and especially how we can visualize results to think about how I want to do that computation. Well, let's start with just something that computes compound interest. I've written a little procedure here called retire. It takes in 3 arguments. The amount I'm going to put aside each month, the rate at which I'm going to earn interest or if you like, grow my income through investments on it, and how many months or terms I want to compute over. How many issues or how many terms do I want to look at before I'm ready to look at retirement? This function should not surprise you. It does things you've seen before. I'm going to set up a list called savings. I'm going to set up a list called the base. That's going to be my Y and X values if you like. I'm going to compute the monthly rate. That's just the annual rate, but every month, so divide it by 12. And then I have a simple little for loop here that runs over the range of the number of terms, so however many times I want to look at this, and it just adds into each of those lists the next label for the x-axis, so the next month. And then the savings computation is a little bit different. I take the value of savings the previous month, and I add to it something that adds in the extra rate. So it's multiplying by 1 plus the monthly rate, which says I've got the savings from last time, plus I got a little bit more because I've earned a little bit more interest off of it. And then to that updated value in my savings, I add in the new monthly contribution. I'm building up 2 lists, and I'm simply going to return those. A base list, which gives me the X labels, if you like, and a savings list, which gives me the Y labels. This shouldn't look surprising to you. This is just a standard little accrual of values in a list of a compound interest plus a new contribution each month. What I want to look at is how do I visualize that? So I'm going to use retire to compute those 2 lists. And notice, by the way, I'm returning both of them. That's very nice. I'm going to use that in a second. Now, I'd like to display that. And I'm going to start by looking at something that's going to display the different growths in retirement accounts as I change how much I put aside each month. I'm going to call this display retirement with monthlies. It's going to take in an argument that is a list of different amounts to set aside each month, a rate and terms as before. And I'm going to start setting up to do the plotting. So I'm going to create a figure with a name. I'm going to clear it as I did before to make sure that in fact I'm going to be able to reuse it. So I'm going to clear that out. And then I'm going to run over a loop. And the loop is going to, in that list of different monthly values, select a new value and run retire. I'll remind you, it said it returned 2 things, so I'm going to get back out the X values and the Y values. And now I'm just going to plot them, just as I did before. Great. I'm going to plot X values and Y values. The one other thing I'm going to do is I'm going to put in a nice label on here that actually says the label is I'm retiring, and I'm going to put in there what monthly rate I was setting aside. So I know how to associate different graphs with the different amounts set aside. And when I'm done with all of that, notice this is going to be a loop. So I'm plotting different versions here. When I'm done with all of that, I'm going to put the legend up in the upper left corner. Let's try it out. I'm going to try it out with a monthly rate of 5%, nice and healthy. I'm going to take 40 years of contributions, so I've got 40 times 12 because I'm plotting these at each month, so that's the total number of terms. And I'm going to look at what happens when I decide to put different amounts aside each month, from $500 up to $1,100 each month. And if I do that plot, nice. Now, the legend's a little big here. I stuck it in a corner where I know it would show up, but the labels are valuable because they tell me how do I correspond each color to the different graph. And you see the growth, the exponential growth that you would expect here as I slowly grow up each one of these different terms. So I've got a set of graphs over here. I can see what those differences are. I might want to zero in on those a little bit to look at some things about each one of those pieces in order to decide which one is better for me. And in particular, I can see the impact of increasing the monthly contribution. I get things that range from about $750,000 to almost 1 2/3 million as the monthly savings go from $500 to $1,100. Again, my point was to look at how do the visualizations help me think about the computation. This lets me see the range of growth as I change the monthly component. What's the effect of the rate of growth on the investments? Well, I could do the same thing. I could write another function, display retirement now with rates. And here, I'm going to give in a list of different rates. I'm going to pick a particular monthly contribution. I'm going to give it a set of terms to look at. And the rest of this looks much like before. Again, I'm going to put a label on here that lets me understand what I'm capturing. So notice, it's got the string retire, it's got the monthly rate, and I'm also going to put something in here that tells me the actual rate of investment growth so that I can associate each of those pieces with the graph. I'm going to give it a particular argument. I took something about in the middle, 800. I'm going to give it 3 different ranges of growth in terms of investment rate. And again, I'm going to give it the same number of terms. And now if I do the graph, I see that there's a different variation in the exponential growth. Here, varying the rate of growth of the investment return actually tends to spread out more rapidly the actual graphs that we see here. But again, I can now start seeing the range of variation here. I can see that, in fact, if I can have something with an aggressive growth, and hoping for 7% is probably being a little bit optimistic here, I actually end up with a much better range in terms of the total amount I've got in my retirement account when I'm ready to retire. Sounds nice. So here, I can see the impact on a different dimension. Now it goes from about 600K to almost 2.1 million. Okay, I want to look at both rates together. What happens if I both think about I want to change how much I'm setting aside each month, and I'm going to be conservative or aggressive in what I want to do in terms of my investments to decide how to get growth in terms of my, my actual and overall retirement account. So I can do both at the same time. It's a little bit more messy code, but you've seen both pieces of it. Now I'm going to have a list of monthly rates. I'm going to have a list of different rates in terms of what I expect of the return on investment, saying am I conservative or aggressive in how I do all of this. I'm going to set up a figure with an appropriate label on it. I'm going to clear it out. I'm actually now going to zero in on just the high end of the range. And here I probably should have, rather than giving it explicit values, looked at the range of terms and set it up. But I happen to know what I was going to use here. So I'm just going to look at the last 10 years of investment on these pieces. So I'm going to literally separate out the X limit on that. Notice, previous examples I set the Y limit. Here I'm choosing the X limit, the X axis, and just zeroing in on one piece of it. The last piece of it is I'm now going to loop twice. I'm going to loop over how much to set aside each month. And for each of those choices, I'm going to loop over different rates of return. As before, I'm going to set up a label, and that label is going to help me out. And now I'm going to look at 4 different monthly rates, 3 different returns, and let's see what happens when we do that graph. And I should have said that. I'm just going to focus on that last stage of the fund. And if I do that, and I put on the appropriate label, I get yuck. Well, the labels help me here. They tell me what's going on. Zeroing in on just the last 10 years was probably valuable because it lets me spread these out. But it's a little hard to figure out which of these graphs is corresponding to which color. So I ought to be able to fix that so I can really see more appropriately the comparison. And I remind you that was one of the points. How do I use the visualization to help me decide how to think about the computation? Here, there's too much overlay of the graphs. How could I separate those out into pieces that would really help me think about this a little bit better? So let's do that. I can't distinguish because of the overlap of the graphs. I could just analyze them separately, but I can also be careful about how I want to visualize the different effects. And I'm going to do that in the following way. As before, I'm going to set up a graph, clear it out, focus in on the last 10 years of all of this. But I'm going to do a couple of other things. The first one is I'm going to create a set of labels. I'm going to create a set of monthly labels, R, B, G, and K, for red, blue, green, and black. I'm going to set up a set of rate labels. And I'm going to now use, notice, the color to tell me what was the monthly contribution. And I'm going to use the style of display, solid line, circle, dash line, for example, to tell me how I want to actually visualize the different rates. Inside of those loops, I'm going to select out a month label by doing the following wonderful little trick. I pick out a monthly rate from that list of monthlies, and to get the month label, I'm simply going to take the remainder after dividing by the number of those pieces to tell me which label to use. So it's going to walk through the labels one at a time, and if I have more choices than I have actual labels, it'll cycle back to the beginning. But this is going to let me select out the label. I'm going to do the same thing with the rate label. I'm going to pick it using the remainder function so that I cycle through those choices. And then when I do the display, I should get something that better separates out the visualization. So let's see if that actually happens. I'm going to create that label by putting those two pieces together. Remember, to do the label, I need both a color and a style. And so by putting those two pieces together as a string, that's going to give me the piece I'd like. And there we go. This may still look messy to you, but this is actually nice because notice the color all corresponds. For example, red is all 500. Blue is all 700. So the color tells me very nicely what was the monthly rate. And the style, solid line, circle, dash line, tells me whether it was a return of 3, 5, or 7%. And while there's still a little bit of overlay between these graphs, it's now easier to see what's the impact. Which one has a bigger impact? In fact, it's being more aggressive about your investments that has the bigger impact because that shifts things up much more rapidly than basically how much I set aside each month. You can see that the slant of the line, if you like, up here with the 3 or the 4, actually, I should have done that right, the 4 dash lines is much better than the slant of the line down here with the 4 solid lines. And that was my original point. I want to be able to visualize and use the visualization to guide the computation. And this says, start saving early for retirement because you really want to do that to get that wonderful compound interest rather than relying on getting a 25% return each year because that suggests that somebody's convinced you to invest in a Ponzi scheme and it's not a good idea. Whatever you do for your own retirement, you get the idea. I can visualize the data. I can use that visualization to guide the computation. And so that nicely leads to this summary. It's now easier to see the grouping of the plots. Color encodes, in this case, monthly contribution. Format, solid circle dashed, encodes the rate of growth that I chose for the investment. And more particularly, as you saw with this example, I can interact between the plotting routine and the computation to explore the data. Can change the display range to zero in on a particular area of interest. In this case, it was the last 10 years. I can change the set of values and visualize the effect, and that then guides a new choice of values to explore. What if I wanted to look at different rates of return? What if I wanted to look at different monthly rates? And finally, I could change the display parameters to highlight how to cluster plots by parameter. If you choose to take the second half of this course, you're going to see lots of nice examples of using plotting to visualize data, to think about what it says about a computation. But we also wanted you to see an example of using a library. And notice throughout this entire lecture, all I did was use a set of functions that I could look up inside a PyLab. That lets me rely on somebody having written code I can use and using that library. a tool you're going to use a lot as you move on in your own computation.